Hello, and thanks for clicking on this next pre-organized production. Today, we're going to be talking about solving trig equations, part 2, where you actually end up going around the unit circle and finding answers multiple times around the unit circle. Okay? All right, so let's get started on it, and we'll see how it works. Okay, so same directions as the other video. I want you to solve each equation on the interval 0 to 2 pi. Again, that means that if you have an answer that's here, the answer is 0, not 2 pi. Okay? All right, so let's work with our first example here. This is similar to what we did before. Tan x equals minus radical 3 equals 0. So we're going to add radical 3 on both sides. We get tan x equals radical 3. Now, where's tangent? Tangent's y over x. Where's tangent positive? Quadrants 1 and 3. I need to know where tangent's radical 3. So that means one of two places. It means the point's either 1/2 radical 3 over 2 or radical 3 over 2, 1/2, one or the other. And hopefully by now you recognize that this is the one that's going to give you radical 3 as your answer, y over x. Okay. This point is pi over 3. So you got pi over 3 here in quadrant 1. And then in quadrant 3, that's 4 pi over 3. So there's my two answers. Pi over 3, 4 pi over 3. Again, you could take pi and add pi over 3, right, to get this angle. 4 pi over 3 there if you want. Okay, or you just know it off the top of your head because you've been doing it for what feels like months. All right, that's how we solved that. We did that in the last video. But what do you do if you're asked to solve this? Tangent 2x minus radical 3 equals 0. Well, it's actually very similar to what we just did. Okay? Almost exactly the same, except for the 2x. So what does this 2 do? This 2, okay, will tell you how many revolutions to make on the unit circle. All right, so what this means is you're going to go around the unit circle when we solve this problem twice. Okay, and I'm going to show you how you do that in just a moment. It's not complicated, all right, but you're going to have to go around the circle multiple times. All right, and then what is that going to do to our solutions? We'll be able to look at it in just a minute. Okay, so the first thing you're going to do is the same thing we did before. We're going to add radical 3 on both sides. So we get tan 2x equals radical 3. All right, now from here, we're solving it just as we were before. So where's tangent positive? Quadrants 1 and 3. The angle that we're working with in quadrant 1 is pi over 3. In quadrant 3, it's 4 pi over 3. Okay, so there are my two angles there. So now, here's what I'm going to do. It's not x that's equal to pi over 3 and 4 pi over 3. It's 2x that's equal to pi over 3 and 4 pi over 3. But the 2 means that I'm going to rotate around the unit circle twice. So my first time around, I get the answers pi over 3 and 4 pi over 3. If I go around another time, I'm going to get 2 more answers to this problem. So there are going to be 4 total answers. Okay? To get those other 2 angles that we're looking for, I'm going to have to take pi over 3 and add 2 pi to it because I got to go all the way back around again. 2 pi over 3 is really 6 pi over 3, so that's 7 pi over 3. I'm going to write that there. And then I got to take 4 pi over 3 and add 2 pi to that. So 4 and 6 makes 10 pi over 3. Okay, so there we go. I went 4 times around the unit circle. Or I'm sorry, I went twice around the unit circle. First time around, I got 2 answers. The second time around the unit circle, I got 2 more. First time around, I got pi over 3 and 4 pi over 3. Second time around, I got 7 pi over 3 and 10 pi over 3. But now, here's the thing. I want to solve these equations for x. Right now it says 2x equals that. So to solve this, I need to divide by 2. But we're going to be a little bit strategic about dividing by 2. Instead of dividing by 2, we're going to multiply by a half, because most of these are already going to have denominators. So if I multiply them by half, it still knocks out the 2 on the left-hand side, and then I can just multiply all the denominators by 2. So I get pi over 6, 4 pi over 6, 7 pi over 6, and 10 pi over 6. 4 pi over 6 is really 2 pi over 3, right, in lowest terms. 10 pi over 6 is 5 pi over 3. So I get 4 answers. 5 pi over 3, 7 pi over 6, 2 pi over 3, and pi over, I don't know what I'm going for here. Trying to loop all the answers around together. There we go. Okay, that sort of worked. And those are my 4 answers to this problem. Okay, so this number, if it's being multiplied by x, it's telling you you're going to have to go around the unit circle multiple times and find more answers than you find just the first time around, like you do with just tan x. All right, let's try sine of 5 theta equals -1. Okay, so now, if you understood what I just did in the last example, you're thinking, oh my God, 5 theta. Okay, because 5 theta means you're going to go around the unit circle 5 times. But it's actually not so bad. I want to know where sine is equal to -1. Well, sine is -1 here. That's at 3 pi over 2. But that's the only time it's -1. So there's only one answer if you go around one time. You go around once, there's one answer. So 5 theta is going to equal 3 pi over 2. But I'm not asking you to go around once. I'm asking you to go around 5 times. So every time you go around, you're going to get another answer. So in total, you're going to get 5 answers to this, because you got to go around 5 times. Every time around is one answer. So to get the next answer, I got to do 3 pi over 2 and add 2 pi. All right, stick a 1 underneath, multiply by 2. So that's going to be 3 pi over 2 plus 4 pi over 2. That's 7 pi over 2. So that's another answer, 7 pi over 2. All right, now I got to go another 4 pi over 2. That's 11 pi over 2. That's the third answer. All right, and now I'm going to add another 4 pi over 2 to 11. That's 15 pi over 2. And I'm going to do it one more time. That's 19 pi over 2. So now I want to solve this for theta. I don't care what 5 theta is. I want to know what theta is. So I'm going to multiply all of these 5 answers by 1/5. So theta is 3 pi over 10, 7 pi over 10, 11 pi over 10, 15 pi over 10, and 19 pi over 10. And those are my 5 answers. And notice the very last answer, 19 pi over 10, is just short of 2 pi. And I'm asking you to solve this equation for all the angles between 0 and 2 pi. 19 pi over 10 is just short of 20 pi over 10, which would have been 2 pi. So this answer is a good answer. Okay? All right. Let's try 4 cosine 2 theta plus 2 equals 0. So this is like me trying to solve 4x plus 2 equals 0. I would subtract 2 and divide by 4. I'd get -2 over 4, which is -1/2. Okay, I'm going to do the same thing over here. Subtract 2 on both sides. 4 cosine 2 theta equals -2. Divide both sides by 4. Cosine 2 theta equals -2 over 4, which is -1/2. All right, so cosine has to be negative. X coordinates negative in quadrants 2 and 3. Where is cosine -1/2? It's a half. Pi over 3 is the reference angle. So the angle in quadrant 2 is 2 pi over 3, and in quadrant 3, it's 4 pi over 3. Right? You can do pi minus pi or 2 pi over 3, pi plus 2 pi over 3 to get that answer. So let me erase this. It doesn't belong there. And I'm also going to erase this reference angle because I don't need it anymore. All right, so 2 theta is going to be 2 pi over 3 and 4 pi over 3. Okay, but it's 2 theta. I got to go around the circle twice. So that's once around. I got 2 answers. I'm going to go around again. I'm going to get 2 more answers. So 2 pi over 3 plus 2 pi. That's multiplied by 3. 2 pi over 3 plus 6 pi over 3. It's 8 pi over 3. And then 4 pi over 3 plus 8 pi over 3. Whoops. Plus 8 pi over 3. No, plus 6 pi over 3. 6 pi over 3. That's 10 pi over 3. 10 pi over 3. But now I want to solve for theta, so I'm going to multiply all of them by a half to knock out the theta, or knock out the 2. I get theta equals 2 pi over 6. You could also cross cancel if that's easier. I think that's actually easier. I cross cancel the 2 with this 2. Leaves me with pi over 3. Cross cancel the 2 with the 4. Leaves me with 2 pi over 3. So you can either multiply straight across and reduce or cross cancel. 8 and 2 would make 4 pi over 3. And then 10 and 2 would make 5 pi over 3. And there are my 4 answers. That is done. Okay? And again, if you want to check, all 4 answers, if you plug them in for theta, they'll work. Okay, let's try tan theta over 2 equals negative 1. This is a little more complicated. At least it looks a little more complicated. Well, let's rewrite this first. Theta over 2, we did this a lot when we did graphing, is 1/2 theta. So what this means is that I'm only going to go a half a time around the unit circle. I'm not going to go all the way around, only halfway. All right, so tangent has to be negative 1. All right, so let's see. Tangent is negative in quadrants 2 and 4, right? Y over x. Tangent's negative 1 when the 2 coordinates are the same. Pi over 4 would be my reference angle. So I'm going to look at 3 pi over 4 and 7 pi over 4. But here's the thing. So 1/2 theta is going to be, but I'm only going halfway around. So the only answer I touch here is 3 pi over 4. I don't touch the 7 pi over 4. But I'm going to show you in a minute what happens to it, okay, and why that we actually don't use that answer. All right, so let's just finish it first. So I'm going to multiply by 2 over 1. I can cross cancel. 2 and the 4 makes 3 pi over 2, and that's my answer. Or it could be 6 pi over 4, which is 3 pi over 2. This is my only answer. But let's look at the 7 pi over 4 just so that you can understand what's happening. Let's say 1/2 theta was equal to 7 pi over 4, and I multiplied both sides by 2. Theta would be, cross cancel that, make it 2, 7 pi over 2. Well, here's the problem with 7 pi over 2. 7 pi over 2 is more than 2 pi, and the answers have to stop at 2 pi, right? This is already, 2 goes into 7 3 full times. That's already 3 pi. Too much. 2 pi is as high as you can go, and you can't even go to 2 pi. So this answer gets thrown out, okay? So you'd end up throwing out that answer anyway because you never reached that far in the unit circle. You only went halfway around it, all right? All right, let's try cosecant of 3 theta over 2 is equal to negative 2. So, okay, so I can do a couple things here. Instead of doing cosecant is negative 2, I'm going to do the sine of 3 over 2 theta equals negative 1/2. Got to find the reciprocal. Negative 1/2. Okay, 3 over 2, that's 1.5. So I'm going to go 1.5 times around, and the sine has to be negative 1/2. Okay, sine is negative in quadrants 3 and 4, right? Sine's the y-coordinate? Yeah. All right, and then sine's a half. Pi over 6 is the reference angle, so this angle is 5 pi over 6. This angle is 11 pi over 6. All right, so 3 over 2 theta would be 5 pi over 6 and 11 pi over 6. Okay, that's the first time around. Now, if I go half a time around, I'm going 1.5 times. If I go another half, this pi over 6 is no good, right? Because it's not negative there. If I go another half a time around, there are no more answers. I don't get to 5 pi over 6. 5 pi over 6 is too far, right? It's too far along the circle. I only get halfway. There's no answers up here. So then I only get these two answers. That's it. I don't get any more. So I got to multiply them both by 2/3, though. 2/3, and I'll cross cancel again. I get 5. Oh, no, you know what? I'll just multiply straight across. I got to multiply both of them anyway, so I might as well just multiply straight across. I get 10 pi over 18, and then I get 22 pi over 18, which I'm going to reduce to 5 pi over 9. 2 goes into both, and 2 goes into both. 11 pi over 9. These are my two answers. And that's all done. Okay? All right, and that's it. Okay? So this number that's being multiplied by the variable, the theta or the x, is telling you how many times to rotate around the unit circle and how many answers to actually find then before you actually finish the problem by moving that number there to the other side, that coefficient. Okay? And as always, that's it. Thanks for clicking.